If it does it again, I'm going to cry. Okay, you look at a triangle, that's your angle we look at. Remember, hypotenuse always stays the same, doesn't move. Yes? Hypotenuse is the only one that doesn't change. Your adjacent and your opposite, make sure you sign in, Maximilian. You have to, Max, you have to use the code. You did it already? Perfect. Okay. So, opposite and adjacent move depending on what angle you're looking at, correct? Well, we're always looking at the central angle. So because we're always looking at the central angle, our x is always our adjacent, our y is always our opposite, and the radius is always our hypotenuse. True fact? Because we're always looking at the central angle. The only way that the adjacent and opposite would switch is if we were looking at this top angle, because the 90 doesn't affect it. But we're never looking at that top angle. So your x's are always adjacent, your y's are always opposite, your r's are always your hypotenuse. So we would have opposite over hypotenuse because it's so, and then this is ka, so adjacent over hypotenuse, and this is toa, so opposite over adjacent. So the y's just replace the o's, the opposites, the x replace the adjacent, and the r's replaced by hypotenuse. But you can use tactics to remember it. So I always say sign your resume, but you don't actually sign your resume, but you could. So I use sign your resume to remember it, and then I do cook extra rice to remember coast, and then tan, why not, your Xbox, so it doesn't have a vitamin D deficiency. Take it outside, okay? Someone thought tan your xiphoid process was better. You do you, whatever works for you. So cook extra rice, sign your resume, and then tan your Xbox. That's how you can memorize them. All right. For points, if it says it's on the unit circle, if it ever says something is on the unit circle, your x is your cos, correct? The x coordinate is the cos ratio. The y coordinate is the tan ratio. That's a lie. X coordinate is the cos ratio. The y coordinate is the sine ratio. So if I give you just a random triangle, I just give you a random coordinate, and that coordinate is not on the unit circle, you have to find your x, your y, and your r, correct? But if I give you a coordinate that is on the unit circle, cos is just whatever the heck the x answer is of the coordinate. Sine is whatever the y answer is of the coordinate. So if the coordinate is on the unit circle, you have cos and sine immediately. If the coordinate does not have a radius of 1, it's not on the unit circle, you actually have to figure out the trig ratios by going adjacent over hypotenuse for cos, or x over r. Now, since cos simplifies to x and sine simplifies to y when it's on the unit circle, you can write cos and sine, Calgary Stampede. We talked about that yesterday. Now, the other thing you need to know is that there are 3 primary trig ratios, but there are also 3 secondary trig ratios, which are their best friends. If you don't remember which trig ratio goes with which, this would be a time to have your formula sheet and unit circle combo out, always. It's always out. Because on your formula sheet, it tells you what goes with what. So when some people mix them up, I'm like, okay, you just say look at your formula sheet. So on your formula sheet here, it says cosecant is 1 over sine, secant is 1 over cos, and cotan is 1 over tan. So you know which ones they go with, right? If you don't know, you can go to your formula sheet, it tells you. The secondary trig ratios are actually the reciprocal trig ratios of the previous one. So for example, sine is sine your resume, correct? We agreed? Y over r. Cosecant is 1 over sine. So it would be 1 divided by y over r. What do we do when we divide by a fraction? Invert and multiply. So we're going to get 1 times r over y, which is just r over y. Do we agree? So every secondary trig ratio is a reciprocal trig ratio of a primary because it's 1 over something. And whenever you do 1 divided by something, it just flips that second half, correct? So people will say sign your resume, and then they'll go, okay, cosecant is resume your, because they flip it in their head. And then cos is cook extra rice, so then secant is rice extra. And then tan is your Xbox, this is Xbox your. It's always a reciprocal trig identity. So it will flip, yes? Because it's 1 divided by the previous one. Does that make sense? So your primary trig ratios are the 3 that we've learned before, sine, cosine, and tangent. Your secondary trig ratios are cosecant, secant, and cotangent. Then we go through cast rule, which we've talked about already. So we know the quadrants make the word calculus. Or crystal. That's my name and I'm Crystal. Calculus, cool, whatever you want. That is the actual quadrant. But cast actually starts in quadrant 4. Another way people do it is not saying cast, they say all students take calculus, which is not completely true, but they do it that way, starting in quadrant 1, all students take calculus. You know, like in piano or whatever, it's like good students do fine, blah, blah, whatever, like FACE, F-A-C-E, the stupid little acronyms. Same thing, if you don't know, but it's okay. Here you can go, all students take calculus. I don't even remember them anymore, and I have grade 8 piano, but she gone. Like, not the piano part, but the remembering the acronyms. Mine was like garbage bags. Oh, yours are way better than mine. Good boys do fine. Always.
We also had even God dog food. That was the one.
So, what CAS tells us, or all students take calculus tells us, is where that trig ratio is positive. So all of them are positive here. Sine's positive here, tan's positive here, cos is positive here. Do you understand why, though? You actually don't need CAS to know where they're positive. Because if you think about it, everything's positive here, because what are your coordinates in the first quadrant? Positive. So your x is positive, your y is positive, and then your r is the hypotenuse, correct? R is a radius. A radius is a length of measure. Radius always has to be positive. So you technically, in quadrant 1, have an x positive, y positive, r positive. So no matter what ratios I divide, they're all going to be positive, correct? X divided by r, y divided by r, x divided by y divided by x, all positive, because all positive numbers. We agree? All right. Now this one, what's negative in quadrant 2? My x is negative. My y will be positive, and my r is a radius. Radius is always positive, correct? So the only thing that is negative is x here. So any trig ratio that contains an x will be divided by a positive. And what is a negative divided by a positive? Negative, correct? So if I looked at, for example, sine is y divided by r. And what is y divided by r? It's positive divided by positive, so sine is positive there, correct? Okay, what about its bestie, cosecant? It's just the flip of that. R divided by y, so it's still positive, right? So not only is the primary trig ratio there positive, the secondary trig ratio is also positive, because it's literally that fraction flipped. If the fraction is positive and I flip it, it's still positive. If the fraction is negative and I flip it, it's still negative. We agree? Now, if I looked at secant, for example, it would be r divided by x. It would be a positive divided by a negative, so that's going to be negative. Its friend cos is going to be negative. Tangent is y divided by x, so it would be a positive divided by a negative, so it would be negative. So the reason why CAS works is because the coordinates there, your x's and y's are positive or negative, and your r is always positive. And so when you divide fractions of positive by a negative, you get a negative, right? So really, we use this acronym and CAS to help us out to find something fast. But it just makes sense because of mathematics you do when you divide fractions with signs. So if I look in quadrant 3, x is negative and y is negative. And what would r be? Positive, because so is positive. So sine is y over r. Well, that's going to be negative. Cos is x over r. So that's going to be negative. Its secondary trig ratios are going to flip, so they're going to be negative. Why the heck is tan positive? Well, it's y divided by x. It's a negative divided by a negative. What's a negative divided by a negative? Positive. And then cotan would be a negative divided by a negative, which is a positive, right? So tan is positive here, and so is cotan. This one, your x is positive, your y is negative, your r is always positive. So whenever y is involved, I'm going to end up getting a negative. Where is y involved in? Sine is y over r. Cosecant is r over y. Tan is y over x. Cotan is x over y, right? So you're going to end up with a negative. Why is cos positive? Well, it's x divided by r, and they're both positive. And then its secondary trig ratio, secant, is going to be r divided by x, both positive. Come on in, friends. Okay. Okay. Does CAS rule make a little sense? Or all students take calculus as to why the heck it is? Because a lot of people just memorize and don't understand. And we know how Mrs. Lepp thinks about that. penny for my thoughts, we need to understand. I would make so much money, even a penny for my thoughts, on telling you have to understand. Okay, so let's look at this one. This isn't annoying at all, this costume. I'm so happy it's a Friday, it's a short one. Given the following point on the terminal arm, does it say given the following point on the unit circle? No. If it was on the unit circle, I would immediately have cos theta and I would immediately have sine theta. Correct? Everyone paying attention, because you guys will give me these as the cos and the sine, and it's not right. So it's just a coordinate on the terminal arm. If the coordinate on the terminal arm does not have a radius of 1, you have to do the trig ratios, y divided by r, x divided by r, y divided by x, to get the actual trig ratios. Okay? So this one does not say that. It says, given the following point on the terminal arm of some rotational angle, find the exact value for all 6 trig ratios and the rotational angle. We're not doing the rotational angle today. We will do that on Monday. So let's, first off, what should we do with it when we get a coordinate? There's 2 answers I would like. There's many probably correct ones, but there's 2 I would like. When you get a coordinate, what should you do to it? Starts with the letter L, rhymes with fable. Label. Then answer, backyardigan. Answer.
No, that's right.
X, Y.
Take the risks for us.
Take the risk, because you never win if you never take a chance.
Alright,
Yeah.
next time.
Okay, first step, label it. Second step, what should you do? Label it. -2, -6, and then draw it. 1, 2, 1, 2, 3, 4, 5, 6. Now, we care about reference angles. Reference angles are our best friend. If we have a reference angle, we can find any angle. We could add it to 180, we could subtract it from 360, we can do all the things. Here. So we need, bless you, Guten Tag. Okay, so we need the reference angle. The reference angle is the bow tie angles, correct? So the bow tie angles are drawing triangles with the x-axis, yes? So whenever we draw triangles, we always want to get reference angles, so we are never going to draw an hourglass shape with the y-axis. So you always come from the central angle out, and then you always draw towards the x-axis. Do you see that? Bottom of the bow tie. All right. So, I'm not against memorizing tactics, but understanding why you do it matters as well. Okay? So here we have x equals -2. Make sure you label it correctly. Y equals -6. Guys, we're in quadrant 3. This coordinate is sitting right in that little quadrant. What trig ratios are going to be positive? Tan and cotan. What are going to be negative? The rest. Yes? Okay, so currently I can do cotan and tan. Yay, let's do those. So tan, ooh, you know what I don't like? This. Tan equals a good dark skin. That is all that tan equals. Okay? You know, like a nice tan. I do like myself a nice tan. I kind of stay away from it. My dad has skin issues, so I don't want to say skin issues. That's all that tan equals. So those of you who write tan without the angle beside it, that is all you're giving me. And then you're like, Mrs. Lepp, but you know. No, I don't. No, I know that word says tan. That's all I know. Now this is, watch this. This is tangent because it actually has an angle beside it. Yes. Nothing makes my heart sing more than a good angle beside the word tan, cotan, sine, cosine. Just makes my heart sing. Legitimately. Okay, so it's tan your X box. What's the your? Tan your X box. Which of these is your? -6, X box. -2, which is? +3, which is good that it's positive. It should be. It's in quadrant 3. Cotan, or cot, if you choose to not put the theta, or you say it weird, which is what some people do. It's cotangent theta equals, it's tan your X box, so this is X box your. Or we could just say what? If this is 3, this is 1/3. Okay, now I'm going to go to sine. not sin, sine with an E. I don't need to write the sign though because I'm doing the angle and then it says sine. Equals sine your resume. Right? Okay. So it's going to be -6 over oh, darn it. Darn tootin', I don't know what that R is. Anyone have any inkling as to how to possibly get it? It's this thing. Pythagorean theorem. Yes. You were made for this. I need that Barbie song. What were you made for? Okay, this moment. So R squared equals x squared plus y squared. So R squared equals 4 plus 36. R squared equals 40. Square root plus or minus. And everything square root, but it's a radius, so what's it always going to be? Positive, because it's a length of measure, right? You can't have a negative length of measure. It's a scalar quantity, not a vector quantity. Okay, so we have R equals square root 40. How can I reduce square root 40, friends? Let's go back to grade 10. Take out a 4. So we could rewrite it if we so chose to show a middle step. We could go 4 times 10, and then the 4 comes out and it is a 2, and the 4 cancels. So R equals 2 root 10. True statement? True statement. All right. So we're going to get -6 over 2 root 10. This is why you did the radical unit in grade 11. Fun fact, every single math curriculum 10, 11, and 12 that you do leads you to be able to do calculus. Okay? So the 10 makes you able to do 11 material, 11 makes you able to do 12 material, and the 10 makes you able to do 12 material. It's going to be cool. And then calculus, all of a sudden you'll be like, oh wow, that's how we learned this in grade 10. No joke. Okay? So, sine, this is fantastic, except they're probably going to rationalize the denominator. Okay, so we want to get rid of the square root of 10. On the denominator, we have a monomial, right? Monomial means one term. One term means not connected by plus or minus signs. Okay? So we have a monomial here, one term. When you were in grade 11, you were taught that if you had a binomial radical, you had to multiply by the conjugate. So if it was like root 2 plus root 6, you had to multiply by root 2 minus root 6. So that those two middle terms would cancel off. You get a positive middle term and a negative middle term, and all the radicals would go away. When you have a monomial, you just have to multiply by the radical, because you're just trying to get a radical to go away. So if I have a root 2 in the denominator, if I multiply by another root 2, the rule of radicals is outside times outside, inside times inside. So coefficient times coefficient, radicand times radicand. So if I have root 2, I would go root 2 times root 2, which equals root 4, which is 2, right? So when you multiply radicals by themselves, you actually get what's just underneath because you get the square root of that number. So if I had a cubed, I'd have to multiply it by the cube of that, so like the square root of it. So if it was a 10, I'd have to, a cube root of 10, I'd have to multiply it by a cube root of 100, so I get a cube root of 1,000, which would be an answer of 10. That's if it was cubed. But squares are so nice. You just multiply by itself. So do I need to multiply by the 2? No. If you multiply by the 2, you're just going to be reducing more numbers. Because you'll add a 2 to the top, you'll add a multiplication of 2 to the bottom, and then you'll have to cancel that 2 back off. So if you did forget, and you multiplied by 2 root 10, your life wouldn't be over. You would just have to cancel more off. Not a big deal. So we're going to get -6 root 10, and then 2 times 1, so 2. Root 10 times root 10 is root 100, which is 10. So it's 2 times 10. So we get -6 root 10 over 20, and then you divide by 2, so we get -3 root 10 over 10. Right? Now, what I get a lot of people saying is, oh, cosecant is that flipped. True, but now you're going to have to rationalize it again. What would be a faster way to actually do this one instead of doing that? Yeah, so if sine is sine your resume, cosecant would be resume your, which is just 2 root 10 over -6. And then we just reduce. Now, that is not wrong. leaving the radical in the bottom no matter what anyone says. Majority of the time, though, they will move the negative to the numerator. The catch is you can have one negative, right? If you can have in the bottom, the top, or the middle. Now, it would be negative root 10 over 3, or they could write it as negative completely outside, root 10 over 3. When people are stuck on this, it's because they're trying to go by memorization tactics instead of understanding. What are fractions? Division. Fractions are division, yes? 1 divided by 2, 5 divided by 6, 6 divided by 5. That's all a fraction is, it's division. We agree? So let's talk about it. If I go root 10 divided by negative 3, or I go negative root 10 divided by 3, would I result in the same decimal? Yeah. If I take root 10 divided by 3 and then multiply it by negative 1, which is having this negative sign out, would I get the same decimal? Yeah, it should make sense to you. So I get a whole bunch of people being like, okay, I'm just going to remember. Why remember? Understand. Then you don't have to worry about remembering. You just get it. You won't make a mistake because it makes sense to you. Okay? So any of these three work. I'll box this one. I could box this one. I could box that one. They're the same. Okay. Cos theta is cook extra rice. So cos theta is going to be negative 2 over 2 root 10. I could cancel these off first if I so chose. I didn't do it though on the first one, but you could do it first, is my point. So I have negative 1 over root 10. And then what do I still have to do? Rationalize. So we're going to multiply by root 10, and we get negative root 10 over 10. Then secant, if cos is cook extra rice, secant is rice extra. So secant theta is 2 root 10 over negative 2. Now some people cancel this off and they're going to say, oh, it's root 10 over negative 1. Not wrong, but will they probably write it that way? They'll probably move the negative up and just write it as a what? Negative root 10. Okay, then we're going to flip over. Now I know that one wasn't on the unit circle. Why do I know that one wasn't on the unit circle? Yeah, that radius was not 1. It was bigger. So that, it was 2 root 10. So here's your unit circle with that radius of 1, and then it's outside of it. So down here, actually. This is negative, negative. All right. Go 2. This is xy. This is going to be in quadrant 4. So I'm suspecting that my cos is going to be positive and my secant is going to be positive. Secant theta. And the rest can be negative. Okay, so I have x equals 3, y equals negative 4. This is a ratio that comes up a lot. R equals 5 when you do Pythagorean theorem. Okay? All right. Shame on all your houses. Now you do it with your shoes on. Go. So sine theta is sine your resume, so you get negative 4 over 5. Cosecant is the reciprocal of it, so you get negative 5 over 4. Cos is cook extra rice, so you get 3 over 5. Secant theta is 5 over 3. They are positive. That is good. Tan theta is tan your x box, negative 4 over 3. And cotan theta is negative 3 over 4. Make sure on your page you have the thetas beside your words. If you don't, you did the entire question, no marks. So make sure you have a theta by those words. If not, you just have cot and tan and sin. Okay, this one, negative 12, 13, 5, 13. This is 1. This is 1. It'd be like here. Why like something like this. Okay. So you have x equals More like that, but anyways. You have x equals negative 12 over 13. Y equals 5 over 13. Oh, dag nabbit. Okay, y is 5 over 13. And then when I do r, I'm going to get 1 because it's on the unit circle. So let's get ready. By what?
How wouldn't RG 13? Oh, yeah, wouldn't RG 13 the X over? Oh my goodness, no,
On the unit circle.
On the unit circle. So think about it. It would be, this is your x. Your x is negative 12 over 13. Your r is 1.
Yes. Okay.
So your r is down here as a 1. It goes away. Okay. So because it's on the unit circle, we immediately have cos theta and we have sine theta. Here they are. So sine theta is 5 over 13. It's technically 5 over 13 over 1. Do I need to write the over 1? Because it'd be y over r. R is what? Right? Your cos theta is x over r, so it'd be negative 12 over 13 over 1. So it just stays. Sine goes with cosecant, so it's 13 over 5. Secant goes with cosecant, so it's negative 13 over 12. Now tan theta is y over x, or sine over cos off our formula sheet. Okay? Do we ever stack fractions? No, it's easier if you write them out sideways because you're going to flip them. So we're going to get y, which is 5 over 13, divided by negative 12 over 13, which is 5 over 13 times 13 over negative 12, which I'm going to show you something here in a second. Those cancel. So you can write it like this. Okay? The other thing you could do is you could stack them. Watching? You could go 5 over 13 over negative 12 over 13. The catch with stacking is denominators can cancel off denominators and numerators can cancel off numerators because you would start with that fraction, you'd flip it. Correct? So it's the understanding of that. So you could just cancel these off and you would be left with negative 5 over 12. Same answer. Cotan theta is negative 12 over 5 because it's the reciprocal. Okay? The homework that you can complete is not a ton in 4.3. The homework that you can complete in 4.3 does anyone have their homework book handy right here? Question 1 and question 2. Yep. So from 4.3 you can do 1 and 2.